And I found it really interesting because I just read a book, which is a popular book in the Netherlands. It's about ambition, how to drive, let's say, a good ambition in life. And the book is a part of the book is the story about how we get rid of slavery, how we got rid of slavery 150 years ago. And this story is about a UK guy and a Brit, and he thought it can't be true that we have slavery, that we have ships going to Africa, literally collect people, get them to the UK and let them work in our upper class families. And it took him years to start a campaign to stop slavery. And after 10 years, it didn't work out because he was just saying, this is not ethical, we should stop that. And after 10 years, he discovered that the most people that were killed or died on the ships were British soldiers, or British, let's say, marine officers, matrozen, what is that in sailors, thank you. So British sailors, so British guys, white guys, on the ships died, and not the African guys. And then he thought, wow. So he changed the frame, the complete frame, and he said, we should stop slavery because our guys are being killed on ships. And then 10 years later, slavery was illegal. So changing the frame is really interesting if you want to push forward a development. And this is why I found really interesting what you told about the US. We have a different frame. Maybe we should, in a way, maybe we can use that in Europe as well. Thank you so much. Anders Olsson is with us because we're talking about electrification. So let's now take a deep dive, real talk about electrification, because Anders is of EQ Lab. And he is a specialist, a Master of Science in Electrical Engineering. So
thank you.
Good that you are here. Yeah. And you used to work, for example, with Scania and here up in Pendrell, working on their electrification. And then you thought, I'd just start my own business.
Yeah.
Really good. Well, take it away with a big hand, of course.
Yeah. I realized when I wrote this presentation that I'm getting old, because I'm working with electrification project now for almost 20 years. And the first project was actually on Scania with the hybrid bus. And in that time we didn't use batteries, we used supercabs, because that was the only choice at that time. And 2011, we have a request from a customer, because of noise actually, to build the first loader crane. And at that time we used lead acid batteries. I think it was like 1,000 kilo lead acid battery. And we released that crane in 2014 with actual lithium ion batteries, but the batteries was the same cost as the crane more or less, so it's, yeah. And then later I started at Pendrell to electrify different products, and I ended at Pendrell like 1.5 years ago as a global electrification manager. So that is a little bit of my history. The challenges of energy transitions. There are a lot of challenges. And in my opinion, it's getting quite slow. The technology is getting quite advanced. The battery is getting more performance, smaller, better. But if you should electrify a product, there's no standardizations. You need a battery, you need a motor, and you need an inverter. But there's no standardization of how these components communicate with each other. So that is a challenge. And today it's quite easy to find batteries, but many machines, they have more or less customized batteries. And like it was 6 years ago at Pendrell, we built our own batteries. So it's in cell level, and there is a lot of difficulties to do that. But there is also like old mindset in the business, and there is like culture mindset. Like this machine has a combustion engine, and everyone knows how to start it, how to use it, how to refill it, and so on. And change that to like electrified solution that is, yeah, I think it's easier to just keep on doing what you have done so far. Energy-wise, it's in the past, like if you have a machine and need more power, you buy a bigger engine. You don't focus on the efficiency. So many machines, they are quite useless in efficiency, energy efficiency. So that is another thing. And for challenge for OEMs is like, how do you perform as good as the like machines that are using combustion engines? And yeah. So and it's also very hard to get components, and it's very expensive to like engineer a system with different components and different suppliers and so on. It's require a lot of engineering. So I'm looking forward for standardization, like Lego pieces. So you just use the motor and the inverter and the battery, and yeah, make it much easier, because it can be like that. And for rental companies, standardization, total cost of ownership, and the battery is one of the biggest expense. So it's to have like a machine, you have like a battery for every machine that costs a lot of money, and you need a charger for every machine, and that costs even more money. So it's can you like have one battery that you use to the machine that you're using at the moment and so on. This slide looks quite boring, but for me this is the best part of the energy transition, because this is the biggest challenge. Because I have seen like machines that have an efficiency of less than 10%. And if you should put like an electric solution on that kind of machine, you need like a big battery pack. But with quite like easy changes of the system, you can increase the efficiency a lot. But back in the time, you didn't think so much about the efficiency. You just buy another motor, bigger motor, or so. And the battery is, I mean, if you reduce the efficiency 2 times, you can have a 2 times smaller battery, and the cost will be 2 times less. So this is like one of the most important parts that people who work with this transition realize, that the battery is in many cases the biggest cost. But if I can reduce that, I can save a lot of costs. This is a machine that I work with a lot, and it's quite common in the rental business. It's for railway truck maintenance. This one we will plan to electrify, and we actually tried with a power head and realized that we couldn't use that because we ran out of energy quite soon, and we had other electrical machines that could do a lot more work with less energy. So then we start to do like a really deep research in how much energy it actually consumes and how much energy we actually need to do the same work. And this become one like project that the product will be actually cheaper to electrify, because this machine has like a combustion engine, it has a gas tank, an oil tank, a filter, a valve, a control system, a lot of couplers, and this part have a weight of almost 100 kilo. And one requirement was it should be carried by people. So it needs like 4 or 5 men to carry this to the truck. But to actually thinking another way, if we replace the hydraulic system with electrical actuators, we can actually remove a lot of parts. And we could even realize that we could replace 100 kilo with 12.7 kilo battery, which makes it a lot cheaper, a lot easier to produce, and a lot lighter. This is another case study. I think I showed this picture because this is a case study where somebody actually have had success by electrifying like cordless hand tools. Ryobi, they realized that the battery and the charger is the most expensive part. So you buy one battery, one charger. And suddenly people can have all these tools in their home and it's not that expensive. So my vision, or what I believe the future of energy efficient product, it's getting cheaper. It's getting lighter. There will be no service needed. They will be much smarter, because when you have the components that you need to electrify something, you also have like a lot of things to make them like autonomous. They will be emission-free. They will reduce noise. And I know that I live next to a manufacturer of excavators, and they have battery excavators. And the customer, what they realize is the benefit of working a whole day without noise. And it's something they didn't expect me from the beginning, but it's something that has been like a really good selling point. And I also believe that this machine will work faster, or they will work when we not look at them, like robotic vacuum cleaner or robotic land mover, or yeah. So we can still just sit down and wait for somebody to start doing the transition, or I will say that we should call for an action. So for rental companies, I mean, I think it's good if you choose, find a standardized battery system and invite OEMs to use it. And the machines, they will be more productive, there's no service needed, and I think they will be more cost efficient if you can have more machines with less batteries. So use one battery to all machines. And for OEMs, start the energy transition, otherwise somebody else will do it. And I'm pretty sure about that. I think in the end, your products will be cheaper, smarter, and better. And I think you should invest in knowledge before solution. Because I've seen like many companies, they hire another companies to do like a prototype of electrified machines. But then they're still working on the old system. They keep on working with old machines, but I mean, the technology is changing quite fast, and new things get cheaper, things get lighter and smaller, and so on. So this is invest in knowledge, because this will not end, in my opinion. Okay.
Thank you so much. Interesting. Any questions? Michel?
It's interesting what you say when you say find one standardized battery system, because we are in constant conversation with OEMs, and one of top OEM told us about a few months ago, it could be easier for you guys, customers, to come up with a standard. If we like it, we adopt it, rather than we OEMs come up with a standard.
Yeah. Oh, so you're quite positive about that advice of Anders. Yeah. And one of the OEMs told you, but he won't do that in public so far.
No, because they think that they are all competitors and it's difficult for them to come up with standard. Mm-hmm. We would be best place to do it.
Yeah. Anders, so there's one of the OEMs telling Michel that he is willing to.
Yeah.
The question is which one?
Which one?
Any other questions? Yes. There you go.
Very interesting what you're saying about changing your mindset and thinking in the old-fashioned way, especially when the example from all the gardening tools and machines that you only need one battery and one charger, and I also see that at home, of course, the investment value of the machine itself is way much less than having a petrol-driven machine.
Yeah.
When you have that variety of machines, eventually it's less capex what you put into it. And I look then at Michel also, we have within the AOA also a total cost of ownership calculator. This is a new way of thinking at the end. Everybody's saying, yeah, the cost, the investment value is way much higher than normal machines. But when we look at rental companies, you don't have 100% time utilization of those machines. That's way much less. So then you need way much less batteries and chargers for your own fleet. So I think eventually, if this is good calculated, that maybe the total cost of ownership is way much less than we are spending now at the moment. So that's really rethinking. And I think the model of the gardening tools is perfectly good example. Thank you.
It's a compliment. Have you done any calculation on this? Because you're saying it has a lot of potential, and I was thinking, how big is the potential? Can smaller batteries, or maybe using the same battery for different equipment, almost level the cost of, let's say, the old-fashioned engines and the way we do it now?
Yeah.
Because we started the day with saying cost is the biggest problem.
Yeah, cost is the biggest, is what you think is the biggest problem.
Mm-hmm.
And like this slide is, I mean, if you, many OEMs, they don't know the duty cycle of the products. They don't know how much is used. They don't know like the efficiency of the products. And if you can understand this, then you can reduce the size of the battery.
So most of the products and equipment is being built oversized.
Yep.
That's your claim. That's your call.
Yep.
And we should make it with smaller engines, because in practice these oversized engines are not being used.
You should reduce I mean, you should reduce the inefficient parts.
Okay.
Yeah. So I
Maybe a good example.
I'm with you. Shoot, tell me.
So one example that I often use is the same with the vacuum cleaners. If Dyson would not have, let's say, the rotating brush, it would do nothing. So, because they changed the way we design a vacuum cleaner, it works on a battery for almost an hour.
Yeah.
If you would do it in the old-fashioned way, it would die like in 2-3 minutes.
Exactly. That's one good example.
I've got a Dyson with a wire.
And that's
So old-fashioned.
Yeah.
And that's the same probably with lawnmowers. If we continue to swing a blade with a certain speed and create the airflow to pull up the grass, if you rethink about cutting your lawn with a different mowing deck without the airflow, it will really improve your runtime of the battery.
Yeah. This is another good example. You have a loader crane, and if you are a battery and look at this, it's not a lifting device, it's more like an oil cooking device. Because sometimes this uses 80% of the energy to just cook oil and 20% to just lift things. And if you can change that so you use like 3 times less energy to cook oil. I mean, the battery for that truck was like 50,000 euro. Then you can reduce the cost by 3. And then you have a completely different equation.
So how do you feel? Like a loader in the desert calling for this action, or do you have more engineers around you saying this is possible, but we have to look at it from an engineering perspective and see that to fill in the picture in a different way?
Yeah. For me, it's just to prove how much energy I actually consume, and then use the rule of physics to calculate how much energy we need to do this.
Yeah, but do you feel like you're alone, or do you have engineers, friends that have the same call?
I have a lot of friends who have the same call. Yeah.
Yeah?
Yeah.
Okay, good. Just checking.
I was just going to say, if you look at the telematics of a telehandler during its life cycle of daily use, you can see a telehandler sits most of the day idling, and then there's 3 or 4 minutes where it's lifting a pallet of bricks, and it's back to idling again. And that's readily available data from major, I won't name the names, but major telehandler manufacturers nowadays. So from a to a battery transition, you can see that it's only being used when it's being used, and it's not wasted energy. So pretty much reinforcing what you're saying.
The same way of thinking, and he is asking for OEMs and rental companies just cooperate, work together. Rental companies should be on the forefront of the standardization.
Yes, I agree. Totally.
Is that possible in practice?
I think if you take, for example, the telehandler, I think absolutely it's possible. But again, it's time, it's cost, and it's the buy-in from everybody.
Yeah. And the question is, of course, are we on the tipping point of this? If we go back to your call for action, are we on the tipping point that the rental companies will do that, do you think?
I don't know. I don't think so, but...
Have they asked you to help you? Any other questions? Or maybe comments?
When you talk about efficiency, and might be calculation and adjustment about the machine, when we talk about the manufacturer, to do it on the manufacturer side. On the other side, my experience is that the operators which operate the machines, because we are manufacturing the PC loaders, there is another way how to do the adjustment on the efficiency of the using the machine and energy battery. When we talk about mainly about the experience of the operator, and to the other side, to use efficiently the energy from the battery. And for the future, we are thinking mainly about to do the machine clever of the operator, to help him how to operate the machine in efficient way.
Yeah, that is interesting, because you can have an efficient car, but if you drive it not efficiently, it will use, let's say, much more energy or fuel. That's the same story. So there's an issue with the operator as well.
Yeah. Or, I mean, like, if you take the electric cars, suddenly cars get like 500 horsepower. I mean, that's...
Yeah, why is that needed?
It's not needed.
No.
It's just a reason to buy it. I guess it's just a reason to buy an electric car. I don't know.
Yeah.
But I mean, if you just give the user like 100 horsepower, you consume much less energy.
Yeah.
But in that case, it's the user experience.
If we should have kept the cars as small as they were 30 years ago, then we could run a car on benzene with a 1 of 50 and make it very efficient. But because we want to have heavy SUVs, who has an SUV? That's what I mean. They're not so efficient.
I can have another example. I can have a last example. Last example is we have a challenge with the university in Sweden, where they build like a small car that runs on a railway track for 4 person. And the energy consumption they use to drive this car 2 kilometers per person is the same. If you have 1 liter of gasoline, you can go from Sweden to Brazil.
With 1 liter?
1 liter.
With this car over a railway track?
Yeah.
Yeah, because it's on railway track,
Yeah, but still, it's super efficient.
super efficient. So we should have railway tracks on all the streets.
Exactly.
That's what it is. Yes. Anders Olsson with a big hand. Thank you.